First, we have to open the Visual Studio from Microsoft. Okay, and open our file. I have already encoded the file, so it's easy. Cubic regression file solution or cubic regression solution. Click it. It's opening now. Okay, this is the main design of the form that I am going to use. It will input here the number of data points. I will show you some example, two example later. Decimal digit and inputting the values of x and of x and solving for the system of linear equation. Or if you want to evaluate of x for certain value of x, f of x for certain value of x, you can interpolate that and it will show you values here. Okay, let's see the main code. This is the code. I think it has a 300 344 lines. So I will not dwell on explaining to you everything on it. Let's leave it to the expert. Okay, let's try it. And by clicking start, and I will take some data here. This is our main screen, our main panel, main console. You see, have some data here, some sample data. Okay, this one, the modeling with cubic regression taken from a book. Putting the data in the table gives the average. Let's maximize it first. Why in knots of a trident motor yacht for several different engine speeds for x in hundreds of revolution per minute. Take note, it's in hundreds of revolution per minute, the value of x. We have to find a polynomial model for the data, and we have to also to estimate the average speed at the trident. Trident is the name of the yacht for an engine speed of 2400 RPMs. Let's see, this one is in hundreds. So 9 means 9 hundreds. Okay, so we have how many data? 1, 2, 3, 4, 5, 6, 7. To put here the number of data points, 7. And it's okay to have a digit of 5 or 4, maybe 4. Just try it in 4. It's okay to have 5. 5. I have to input the values of x now as was given on this 9, 11, 13, 15, 17, 19, and 21.5. And for the speed of both speed, we have 6.43, 7.61, 8.82. After inputting the number, you press the enter key. 9.86, 86, 10.88, 12.36, and 15.24. And click OK after entering all the values. Check it first. What is you don't miss anything, you don't have an error on anything. Okay, I think I don't have an error. Click OK. So let's maximize our calculator, cubic regression calculator. You can see that this is the summation x, sigma x, and this one is for y or the f of x, and so on and so forth. Okay. Now, if you're going to solve the system of linear equation, just click on here and all the values of a, b, c, d. Okay, so we have to solve to the system of linear equation. Just click here. So A, let's have it very near. You can just click and drag that Microsoft standard. So A is negative 9.58456. B is 3.14342. As was given here, the decimal digit is 5. And C is negative 0.1.19511, and D is 0.00477. A now is negative 9.58456 plus 3.14342 x minus 0.19511 x squared and plus 0.00477 x cubed. Okay, let's go back to the problem. It says here, estimate the average speed of the Trident for an engine speed of 2400. Okay, we only have to input 24 here for the values of x because the speed is in hundreds of revolutions. This one, 9, 11, 13, 15, 17, they are in hundreds of revolutions. Okay, how are we going to do that? So let's click here, evaluate fx for any values of y. So the values of x was given in the problem is 400. Put here 24 and click evaluate. Okay, this one is the answer result. If x is 24, your y is 19 point or f of x is 19.41464. Okay. Okay. For this problem, let's plot it using a graphing calculator or graphing program called Desmos. This one is the Desmos program. Okay, I've already done that. The voting regression is open. Okay, so the are the values. Just input it. 9, 11, 13, 15, 17, 19, and 21.5. So 643, 11.61, and so on and so forth. Okay. So these are going to do it. So you have to add fx expression. After inputting all the data, you have to input the value of y1, 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 y1 is equal to, or you have to use the tilde. Is estimatory. Okay. Start with d first. D is the cubic. X, x1, cube, plus c, x squared, cx1, x squared, plus b, x1. See, graph now is beginning to shape and plus a. Hmm. So our parameter, in valuable statistic, r squared is 0.99.94% or 99.94%. The values are the coefficient. The values of the coefficient is, let us check from our previous data. They are coincide with each other. So A is negative 9.5 here, 9.5 here, almost the same. B is 3.1 here, 3.14 here. And C is negative 0.19. And D is 0.0047. But they're the same. Almost the same. Okay, and the equation is, or the graph is here. Okay, see the points here. Very nice. That's was free, powerful free graphing calculator that can show you the parameters and the statistic. Okay, save. Now let's have another example. Let's go back to our screen, our, our console, the calculator. Our next example is let's have this data. The set of the following five data points is given. So we have here five data points. Let's minimize it, split it side by side, and let's input the values now. So x is 8, 11, 15, 18, and 22. And f of x is 5, 9, 10, 8, and 7. Let's double check. 8, 11, 15, 18, 22, and 5, 8, 9, 10, 8, and 7. Click OK. Okay, let's check. So the summation of x is 74. F of x or y summation of x 39, and so on and so forth. Okay, let's solve now for the values of system of linear equation. A is negative 35.96541. B is 8.67627. C is negative 0.525526. D is 0.00998. The equation now is f of x is negative 35.96541 plus 8.67627x minus 0.52526x squared plus 0.00098x cubed. Okay, let's go back to the problem. Determine the natural cubic spline that fit the data. So this one our cubic spline now. Determine the quadratic value of y for x is equal to 12.7. Okay, if x is equal to 12, we have to evaluate. We have to input here the values of 12.7 x and evaluate what is y, what is f of x when x is 12.7. Okay, he is asking that. Then click evaluate. So if x is 12.7, y now, function y now is 9.9469. Okay, let's see what it looks like in our graph by going back to the Desmos graphing calculator. I've already done that, and let me show it to you. Show data here is 8, 11, 15, 18, 22. It's correct. 5, 9, 10, 8, 9, 7. Okay. The values of the parameter of coefficient is here. Let's check in our console or the cubic regression calculator. They are almost the same, all the same. So A is 36, here is 35.96, and B is 8.67. This one is 8.69736. C is negative 52526. C is negative 526.728, negative also. And D is 0.0998. This one is 0.0. Maybe they are all differs in decimal digit, but they are almost the same. This is the graph. Very nice graph. All its point. The roots. Okay. Very nice. Okay, that's it. Thank you for watching.